In this lesson, we're going to be finding trigonometric values from a right triangle, from the unit circle, and then also using our calculator. So as a review, using the lengths of three sides of a right triangle, you can form the 6 ratios that define the 6 trig functions of an acute angle theta. As a reminder, these are our 6 trig functions. And just remember that sine's reciprocal is cosecant, cosine's reciprocal is secant, and tangent's reciprocal is cotangent. So you might notice that a co is a pairing with another trig function that's not a co. So we got cosecant goes to sine, cosine goes to secant, and cotangent goes back to tangent. Those are reciprocals. And just kind of real quickly reminding ourselves about right triangle trigonometry. We'll go ahead and draw a right triangle here and label our sides. So let's consider this acute angle right here, theta. We could have considered this one up here, but I'm just going to consider this one right here. Remember, this is the adjacent side to the angle theta. This is the opposite side, and of course, this is the hypotenuse in the right triangle. Okay, and just notice that theta is an angle that falls between 0 degrees and 90 degrees. All right, our right triangle definitions of trigonometric functions, they're right here. So we know that sine of theta is opposite over hypotenuse, so the reciprocal is hypotenuse over opposite, etc. As a reminder too, I know we've seen this before, but to help us memorize some of these right triangle trig definitions, we can use the acronym Sohcahtoa. All right, we're going to start by looking at some examples on page 416 in our textbook. So if you have that handy, if you want to reference it, that's fine. So on page 416, problem number 8. See if I can show that real quick. Not sure. Hope so. There it is. There's problem 8. So it's important to read the directions because that gives us a lot of guidance about what we're going to do. So for problem number 8, we're asked to find the exact values of the 6 trig functions of the angle theta that's shown in the figure. Well, if you look at problem number 8's right triangle, you're going to see that it's a right triangle. We have the labeled theta angle that we're interested in. We have the opposite side and we have the hypotenuse. So we can use Pythagorean theorem to find the adjacent side. And once we have all 3 sides of that right triangle, we're going to be able to set up the 6 trig ratios. So let's go ahead and take a moment and record that triangle. So that's problem 8. As best we can. All right, first thing we're going to want to do is we're going to want to find that adjacent side by using the Pythagorean theorem. So a squared plus b squared equals c squared, where c is the hypotenuse. I'll just call 5a. I could have called it b. It doesn't matter. So 5 squared plus b squared. So now I guess that means we'll let this adjacent side be b, equals 13 squared. So we've got 25 plus b squared equals 169 with the help of a calculator. Let's subtract 25. So we get b squared equals 144. Mathematically, the correct thing to do here is bring in the radical. Because we have an even power or even root we're bringing in, we take out the b, but we have to put absolute value around it because it's an even root. Square root of 144 with the calculator's help is 12. When we remove the absolute value, we do get positive negative 12. So mathematically, this is the correct way to find the missing side. But remember, we're not interested in the answer of negative 12 because lengths can't be negative. So as a way to show that we're discarding the negative, we would just rewrite b equals positive 12. All right, let's go ahead and find all 6 trig values. So what's the sine at theta? Don't forget to put theta here. Sine of some angle theta. Well, we know that's opposite over hypotenuse. Let's do cosine of theta. It's adjacent, which is 12 over 13. And we know tangent of theta, which is toa, opposite over adjacent, which is 5/12. Okay, at this point I can find the reciprocals just by reciprocating the fraction. See, I'll probably just put a comma here, I guess. That's a comma. So let's go ahead and find the cosecant of theta, which is just 13/5. Do another comma here. Cosine's reciprocal is secant, so secant of theta here. And then tangent's reciprocal is cotangent of theta, which is 12/5. So let's look at 16. What's the presentation of the problem there? Well, let's see. See if I can get the book back up here. We're going to be doing the same thing, but the given information is a little different. Well, there's 16 right there. It's cosine of theta equals 3/7. So it says in the directions, sketch a right triangle corresponding to the trigonometric function of the acute angle theta. Use Pythagorean theorem to determine the third side of the triangle and then find the values of the other 5 trig functions of theta. So for problem 16, all we're given to start with is that cosine of theta equals 3/7. So the first thing I'm going to do is I'm going to draw a right triangle. I'll label theta. What I do know is that adjacent over hypotenuse, so adjacent is 3, hypotenuse is 7. Okay, I would label the triangle that way. So I need to use Pythagorean theorem to find the missing side. Again, a squared plus b squared equals c squared. And I've done that work. So let me come over here. What happens is once we do that work, we get b squared equals 40. I'm kind of skipping these first few steps to save time. So bring in the square root, an even root, bring out b, but make sure it's absolute value. That's not a perfect square, but I can simplify it. I want to do so. 4 times 10 is 40, and because 4 is a perfect square, I can pull out 2. Remove the absolute value. We're going to discard the negative solution. It's not applicable to the context of our problem. So the missing side is 2 square root of 10. Okay, so from here, let's go ahead and find the 6 trig ratios. So sine of theta. So here's theta, opposite over hypotenuse. Cosine of theta was given already. I probably shouldn't have had to write that down again. That's okay. And tangent of theta. 2 radical 10 over 3. All right, I'm going to do a comma here. I'm going to find the cosecant of theta, which is 7 over 2 radical 10. This is going to require some rationalization here. So I would multiply by square root of 10 over square root of 10. So what I'm going to end up with on top is 7 radical 10 over, and this is going to be 2 times 10, because square root of 100 is 10, so that's going to be 20. And 7 and 20 don't reduce, so I'm good to go there. All right, if we didn't have to rationalize, we would be finished right here, and that would have been fine, but just being able to, you know, present the answer in a different form is important too. Cosine's reciprocal is secant. That was easy. I could have done that from the beginning. That's just going to be 7/3. And then notice right here, cotangent of theta is going to be 3 over 2 radical 10. Again, you'd want to rationalize, and in doing so, I think the answer is going to be 3 radical 10 over 20. Okay. All right, let's take a look at 18. Don't know that I'm going to finish it, but at least we'll get started with it. 18 is in that same group of problems as 16. 18 is the cosecant of theta equals 17/4. Given this information, if I'm supposed to find the remaining 5 trig functions, well, first of all, I have cosecant of theta, so I could find sine of theta, which would just be 4 over 17. So really I only have 4 to find. Let's go ahead and construct a right triangle based on this given information. Here's theta. Cosecant is going to be hypotenuse over opposite. So we'd label our triangle in this manner. We would apply Pythagorean theorem, and what happens is we're going to get, actually it doesn't reduce or anything. When you use Pythagorean theorem, this missing side is going to be the square root of 273. All right, right, so I encourage you to make sure you could get square root of 273 here. And again, like I said, it doesn't simplify. You'd go through and report all the different trig functions here, rationalizing when necessary. All right, this is right triangle trigonometry, finding trig values using a right triangle and the sides of that right triangle. Okay, let's flip over to the back. All right, it says using a given angle, theta, find the trig functions. All right, it says find the exact values. That typically means exact values, no calculator. Find the exact values of sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. Then find the exact values of each of the reciprocals. All right, I have a choice here. I could set up a right triangle labeling one of the angles as 45 degrees, and then remembering that I have 45 degree, 90 degree special right triangle, and use the relationships there to help me. But instead of doing that, instead of using a right triangle, I'm gonna use the unit circle. I recognize 45 degrees as one of those angles that's on the pi/4 circle. So instead of using a right triangle to help me find these exact values, I'm gonna use the unit circle. So if you have that handy somewhere, you might wanna bring that out so that we can reference that. Okay, I thought I had my unit circle. Let's see. Apparently I do not. What happened to it? That's okay. I'll recreate it as we go along. Okay. So let's find the exact values of sine 45 degrees, cosine 45 degrees, and tangent of 45 degrees using the unit circle. So I'm just going to kind of real quickly redraw the unit circle here. I know 45 degrees is right here, half of 90, but remember 45 degrees is also called pi/4 in radian mode. All right, if you have your unit circle in front of you, the ordered pair that exists right here is going to be square root of 2 over 2, and then also square root of 2 over 2. So hopefully you've kind of begun to internalize those and memorize them. Okay, so what's the sine of 45 degrees? Well, remember, we're not on a right triangle, kind of. I mean, a right triangle does, exist within this unit circle, but when we're on the unit circle, the sine of 45 degrees is actually just y over r, where r is 1. So sine of 45 degrees is just going to be the y coordinate. We connect sine to the y coordinate, so the answer is square root of 2 over 2. Okay, if we want to verify that that's correct, let's use a calculator right now. We're done and finished, but I just want to verify that that's the correct answer. So first of all, let's just find out what the value of square root of 2 over 2 is as a decimal. So I'm just going to find out what is square root of 2 divided by 2 as a decimal. All right, I can see it's there, 0.7071, etc. Okay, so now let's go to the calculator and find the sine of 45 degrees. Well, because we're finding the trig value of a degree angle, it's important that we look at the mode key. We're currently in radian mode. Let's go down to radian mode, over to degree, press enter to grab it. Let's go back to the home screen. We're in degree mode. So the sine key of 45, you do not need the degree symbol if you're in degree mode. Press enter. We do get the same answer. Let's see what would have happened had we not changed the mode. Okay, if we're using the calculator and we kept it in radian mode, but 45 degrees is not an angle in radians, so let's see what would happen. I'm going to come back up here and grab sine of 45 degrees, pressing enter, bringing it back down here. Press enter. We do not get the same answer. So you have to be very mindful of the mode that you're in when you're finding a trig value of an angle. Okay. All right, let's find the cosine of 45 degrees. Well, if we're using the unit circle to assist us, let's locate 45 degrees. Let's locate the ordered pair. Let's remember that cosine is the x coordinate, so it's exactly square root of 2 over 2 as well. All right, what's the tangent of 45 degrees? Well, around the unit circle, tangent's relationship is y over x, the y coordinate divided by the x coordinate. Well, the y coordinate divided by the x coordinate would just result in 1. Again, I can check these values on my calculator as long as I'm in degree mode. Let's go ahead and find the reciprocals. So what's the cosecant of 45 degrees? The reciprocal of sine, well, that would be 2 over radical 2. If we wanted to leave our answer unrationalized, that'd be fine. But let's go ahead and rationalize. So I'm going to get 2 square root of 2 over the square root of 4, which is 2, but these 2's would simplify, so my answer is just square root of 2. So now we know the secant of 45 degrees is also going to be the same, so it's going to be square root of 2. What's the cotangent of 45 degrees? Well, when I flip the number 1, I'm still just going to get 1. Okay, let's use the calculator to assist us in verifying that the cosecant of 45 degrees equals 2. So I'm going to kind of give me this little space right here. So I'm kind of front loading because later we're going to do more calculator work, but if we kind of get started with the calculator right now, it'll assist us in speeding up through the last few problems. All right, what we're doing is we're verifying that the cosecant of 45 degrees is equal to the square root of 2. So first of all, let's find out what that decimal is. All right, let's keep that in our brain, 1.414, etc. All right, let's go to the calculator. Now, to find the cosecant of 45 degrees, first of all, make sure that the mode setting is in degrees. So go back to the mode setting. Okay, so we're good. We're in degree. Just double checking. Yeah, I grabbed it. The cosecant of 45 degrees. Well, notice that we don't have a cosecant key. There's no cosecant key here. And this key above, these keys above here of sine, cosine, and tangent in blue, those are not our reciprocal keys. Those are used to find angles given values. Here, we're finding values given the angles. We'll be using these inverse keys later, but not for what we're doing here. So how do we overcome this? How do we check cosecant of 45 degrees when we don't have a cosecant key? Well, here's the thinking. We know that cosecant of 45 degrees has a reciprocal, cosecant does, of sine. So if I take a fraction and put 1 on top and I rewrite cosecant as sine, it's reciprocal, keeping the angle here. If the angle 45 degrees is here, then it's here. Then I know cosecant of 45 degrees is the reciprocal of sine. Then I know that 1 over sine 45 degrees would equal the answer I'm looking for. So if you go to your calculator and just use your fraction template, no problem. Now we have a key that we have available to us on our calculator. Sine of, we're in degree mode, 45 degrees. Press enter. We get the same answer. So finding a trig value of one of these 3 reciprocal functions would require you to do a rewrite using the reciprocal function and then finding the answer on the calculator. Something else real quick to just make you aware that another way to write this fraction is if I took the whole denominator and brought it up to the numerator, then the actual equivalent rewrite would be sine of 45 degrees, wrap it in parentheses, and say that you're bringing it up out of the denominator by putting a -1 exponent here. Well, let's just double check to make sure that that's mathematically correct by going to the calculator, not using the fraction template here, but actually maybe do an open parentheses, sine 45, close parentheses. It's important that you close this next parenthesis right here, otherwise you're going to be reciprocating 45. So you need a closing parenthesis for that opening parenthesis, and then I would hit the reciprocal key here, x to the -1, and then press enter. We do get the same value, so we're good to go. Let's see what happens if I don't use that extra set of parentheses. Let's see if I do sine of 45, and then I use the reciprocal key. Not sure if it's going to give the same answer. Oh, it does. Okay, so it's not necessary to have that extra set of parentheses there. I thought it would reciprocate 45, but apparently not. Okay, so you can kind of eliminate that extra set of parentheses there. All right, we'll return to the calculator at the bottom of this worksheet as well, having some more practice problems. Okay, next group of problems. It says use an equilateral triangle. Well, that means all angles are the same, so that'd be 60, 60, 60 degrees. Use an equilateral triangle to find the exact values of sine of 60 degrees, cosine of 60, sine of 30 degrees, and cosine of 30 degrees. Actually, I'm not going to use an equilateral triangle. I'm going to use the unit circle. To me, that's easier. I already have the unit circle available to me. So instead of drawing a triangle, I notice that 60 degrees and 30 degrees are all going to be angles that are on the unit circle. So in that case, I'm going to go ahead and use the unit circle. So let's look at sine of 60 degrees. I'm going to go ahead and draw another unit circle here. You might have yours in front of you, and that's great. 60 degrees is up here. Locate the ordered pair. That ordered pair is 1/2, comma, square root of 3 over 2. I encourage you to label x and y above it. All right, what's the sine of 60 degrees? Well, when we're on the unit circle, it's y over r, but the radius is just 1. So we just say it's the y coordinate, so square root of 3 over 2. What's the cosine of 60 degrees? Well, that's just going to be the x coordinate, which is 1/2. We're done. Unit circle so much faster if you know that you can use that and it's available to you as opposed to drawing a triangle. That just takes too much time. What's the sine of 30 degrees? Well, let me locate the new angle of 30 degrees, which is here. Remember, the ordered pair starts out square root of 3 over 2 and 1/2. Label x, label y. Sine of 30 is the y coordinate. And then cosine of 30 degrees is going to be the x coordinate. Okay. These are actually, if you notice something here before we move on, okay, I want to talk to you about cofunctions. Cofunctions. Notice that the sine of 60 degrees is equal to the square root of 3 over 2. Well, that's equivalent to the cosine of 30 degrees. It's cofunction. Think of 90 minus 60 degrees in a triangle. Okay, sine of 30 degrees is square root of 3 over 2. So sine and cosine are what we call cofunctions. So if cosine of 60 degrees is 1/2, I wouldn't have to find sine of 30 degrees. I would know that sine of 30 degrees is the cofunction to cosine of 60 degrees, and I could just say that that's also 1/2. So sine and cosine are cofunctions. So if for some reason we knew that sine of some angle, well, no, I can't do that. I have to do something. I have to know the angle. Pardon me. Never mind that. Let's just stick with the cofunctions. Okay. All right, let's move on. Let's find the exact values of the following. The exact values. What's the tangent of pi over 4 radians? So instead of using degrees now, we're going to use the radian measure, but we know pi over 4 is equivalent to 45 degrees. We're going to find the cosine of pi over 4, the tangent of pi over 3. Notice all these angles after the trig functions. They're all angles that are present on the unit circle. So in this group of problems, what I want you to do is have your unit circle handy, go back and see if you can answer, any of these, all of these by using your unit circle. So pause the video, attempt them, and fast forward when you come back to see how you did. Tangent of pi over 4. You've got your unit circle, we're talking that angle. We know the ordered pair, square root of 2 over 2. Same here. Tangent is y over x, so that's 1. Cosine of pi over 4. I'm still at pi over 4. Cosine is square root of 2 over 2. Any other pi over 4 angles? No, I'll move on. All right, tangent of pi over 3. Okay, well, pi over 3, look at your unit circle, is 60 degrees. It's up here. The ordered pair is 1/2 square root of 3 over 2. This is x, this is y. Tangent, remember, is y divided by x. So think about taking square root of 3 over 2 and multiplying by the reciprocal, 2 over 1. So over here, that would look like this. Take the y coordinate, multiply it by the reciprocal. 2's divide out, my answer is square root of 3. I'm going to drop down here to cosine of pi over 3 since I'm still looking at pi over 3. The cosine is the x coordinate, and that's 1/2. So at some point you won't have a unit circle to look at, so you'll want to make sure that you can at least label one of the ordered pairs and then work your way around in case you need those ordered pairs at those different angles. All right, for these two problems, we're talking about the angle pi over 6. So let me get a triangle on here, or a unit circle, excuse me. Pi over 6 is 30 degrees. It's down here. It's less than halfway through quadrant 1. Hopefully you've memorized that ordered pair. This is x, this is y. The sine of pi over 6 is y. It's 1/2. All right, what's the tangent at that same angle pi over x? Or, excuse me, pi over 6. Well, it's 1/2 divided by square root of 3 over 2. So instead, we're going to take 1/2 the y and multiply it by 2 over square root of 3. We'll divide the 2's out. We're going to end up with 1 over square root of 3. If we rationalize, that's going to equal square root of 3 over 3. All right, continuing in this lesson, we have some more examples from page 416, 22, 24, and 26. So if you have your book handy, you might want to kind of pause the video, look at the directions, kind of internalize what we're supposed to be doing. All right. So 22, 24, and 26 says in exercises 21 through 30, construct an appropriate triangle to complete the table. And notice that it says that theta must be an answer. Your answer, if you're coming up with a theta answer down the theta column, your answer either has to be a value between 0 and 90 degrees, or theta has to be a value between 0 and pi over 2. So if we're presented with a degree measure, our answers should be reported in degrees. If in the problem we're presented with a radian measure, then our answers should be reported in radians. All right, so look at 22. They give us the function cosine. Okay, and if we scan our eyes to the right, we can see that they're giving us the angle theta in degrees, but in the next column, they want the equivalent theta in radian measure, and then they want the function value. So I've kind of got that table somewhat recreated here. So on problem 22, what's given is 60 degrees. In 24, we have secant, but we're given the radian measure of pi over 4. And for problem 26, we're actually given not the angles, but the value of square root of 3 over 2. No, excuse me, square root of 3 over 3. And we're asked to work backwards and find these two measures. All right, so cosine of 60 degrees, well, what we're trying to find here is the radian measure. We know that's pi over 3. Go to the unit circle to find the value. The cosine of 60 degrees is going to be a half. So we were given this, and we were asked to find these two missing values. 24, secant of pi over 4. Okay, well, I'm going to go ahead and put down, again, this was given. I'm going to put down that pi over 4 is 45 degrees. At least I've got that filled in. Then I'm going to go to my unit circle to 45 degrees, and I'm going to find the secant. So I think we had, right here in a previous problem, 45 degrees. The secant is going to be the reciprocal of cosine. Cosine is x. Remember, 2 over square root of 2, right up here, okay, is going to be rationalized into square root of 2. So that's going to be the function value. All right, I would say 26 is the most challenging just because you're given the function value of cotangent and you're asked to find out what angle has this function value. Now remember, it tells us that our answer has to be between 0, our degree answer has to be between 0 degrees and 90 degrees. Okay, so I might want to start there, trying to find the degree measure. Then it's going to be easy for me to change that to radians. So these restrictions right here limit us to quadrant 1, 0 to 90 degrees. All right, so you have your unit circle handy. Okay, we really only want to consider, I'm going to do some work over here, quadrant 1. I don't want to consider the 45 degree angle because that's not going to give me a number that looks like square root of 3 over 3. It's either going to be at 30 degrees or 60 degrees. So remember, 30 degrees has the ordered pair square root of 3 over 2, 1/2. And then up here it's a half square root of 3 over 2. All right, and I'm going to label x and y above. So this is x and this is y and this is x and this is y. Okay, so now I'm going to work off this unit circle either at 30 degrees or 60 degrees. Remember, we want the cotangent. Now, cotangent is the reciprocal to tangent, so that means the relationship is I got to take the x coordinate and divide it by the y coordinate to get square root of 3 over 3. Well, when I look at square root of 3 over 3, something I think about is it comes from 1 over the square root of 3 before it's rationalized. So now what I'm going to do is I'm going to put my eyes on these two ordered pairs and just start testing. Let's test this first ordered pair at 30 degrees. If I took x and divided it by y, then I would have square root of 3 over 2 times x divided by y would be times 2 over 1. The 2's would cancel, so the cotangent of x divided by y at 30 degrees would give me square root of 3. Well, square root of 3 is neither one of these forms. So I think I've eliminated 30 degrees. Let me go up to 60 degrees. Let's look at this ordered pair. X divided by y is cotangent. So what's x times the reciprocal? Well, when the 2's cancel, I do end up with 1 over square root of 3. So I'm thinking I need to be at 60 degrees to get a cotangent of square root of 3 over 3. And 60 degrees is equivalent to pi over 3. That one takes a little bit more work when you're given the trig value, especially of something like that. So just kind of persevere, use your mental math, use your unit circle, okay, and then make a prediction, test it. If that fails, then, you know, verify that the other angle is the solution you need. Okay, I'm looking at the time. It's kind of a long video. I get it. It's close to 31 minutes, but this last part right here should go pretty quick. It's using a calculator to find trig values. All right, so make sure your calculator's handy. Okay, these are the directions of what we're going to do when we have to find trig values when we don't have keys on the calculator. Let me start with this first example, though. Let's use our calculator to find the sine at 76.4 degrees. So that's not an angle that comes from the unit circle, 30 degrees, 60 degrees, 45 degrees, etc. So we're going to have to use a calculator to find this value. So what's important? Well, we do have a sine key on our calculator. This presentation of this angle is in degrees, so go to your mode. Yes, we are in degrees. Good. Just hit sine, 76.4. No degree is necessary. Okay, we're going to record to 3 decimals. So 0.972. Don't label the answer. It's not degrees. It's not radians. We found the y value on the unit circle, I guess you could say, at 76.4 degrees. No radian label, no degree label. They presented you with an angle. Your answer has no label on it. Okay, look at these remaining 3 problems right here. It says find the cotangent at 1.5 radians. Remember, this is radians because there's no degree symbol here. This is an angle, but it's presented in radians. Okay, secant of 32.8 degrees. Well, we don't have a secant key. We don't have a cotangent key. So we're going to have to do something different. This is, degrees. What's the cosecant of 1.2 radians? So I don't see a degree symbol here. This is the angle slot. You know, this is the angle position. So you have to look at this and go, oh, there's no degree symbol, so that's radian measure. That will help determine what mode setting you need to be in. All right, so we'll use our calculator for that in a minute. Let's come up here and look at our example. It says set calculator to desired mode. Okay, I'm looking at this angle that's given. It must be radians because I see no degrees. Go back to the mode key. Change it back to radians. Got it. Most calculators do not have keys for these 3 trig functions. But to find the values, we're going to use what we call the reciprocal key to find the answers. Well, I don't have a cosecant key. That's okay. What we did in the earlier problem at the top of this worksheet is we said cosecant's reciprocal is sine. So build a fraction 1 over the sine of pi over 8. You're in radian mode. You could use the fraction key on your calculator and you will find an answer for this. We're in radian mode, right? Yep, sine. Let's make another fraction and we'll put pi on top. 8 down here, close our parentheses, 3 decimals, 2.613. As a reminder, another way to write this is you could actually go straight from the given problem to a reciprocal setup. So remember, if we were to take this entire denominator and bring it up to the numerator, I would have sine of pi over 8, all raised to the -1. So let's make sure that that does correspond to 2.613. We did not need the opening parentheses here, so I think I'm just going to go sine, fraction bar, pi divided by 8. Let's get out of that. And then raise that, this key over here to the left, x to the -1, 2.613. So your preference. If you feel like you can go straight from cosecant to sine, but remember to put the reciprocal key here, that's fine. All right, if you're feeling comfortable with what you should do, I encourage you guys to do these on your own and then come back and check to see how you did. All right, cotangent of 1.5. I need to see either one of two things. I need to see that you've either changed this to the fraction 1 over tangent, it's reciprocal, 1.5 radians, or you need to record tangent 1.5 to the negative 1 power. Either way. I'm in radian mode, correct? Yes, I haven't changed that. So I'm going to go ahead and just do tangent 1.5, close my parentheses, reciprocal key, 3 decimals. 0.071. Since I'm in radian mode, I'm going to skip this next problem so I don't have to keep going back and forth in my mode keys. I'm going to go over to cosecant of 1.2. So again, the requirement is, since cosecant is not a key on the calculator, you need to either show 1 over, this is equal to 1 over sine of 1.2 or sine of 1.2 to the negative 1. .073. And for this last example, we're going to have to change the mode setting. So let me do that first. The presentation is I have a degree measure. Okay, so again, I don't have a secant key. I am in degree mode. This is equal to 1 over cosine of 32.8 degrees. Don't forget your degree symbol. Or straight to the reciprocal cosine 32.8 degrees raised to the negative 1. I don't need the degree symbol here if I'm in degree mode. 1.1, oh, that's interesting. 1, 2, 3, that 6 is going to bump that up from an 89 to a 90, so 1.190. And if I am told to round to 3 decimals, I need to put that 0 there. Don't cut it off to 1.19. All right, so in this lesson, we found trig values by revisiting right triangles, by revisiting the unit circle, and then also learning about our calculator.